Good morning, everyone. Today, we turn our attention to a region that is not only geographically distant for many of us, but profoundly connected to our global climate system, the Arctic. This vast, icy expanse is undergoing rapid and unprecedented transformation, acting as a critical barometer for the health of our planet. The changes occurring there are not isolated events. They represent a scientific analysis of accelerated warming and its far-reaching consequences for every corner of the globe. Understanding these dynamics is crucial, as the future of the Arctic directly influences our own. We must recognize the urgency of this situation and its implications for our collective future. The Arctic stands at the very epicenter of our global climate crisis. It is warming at an alarming rate, approximately twice as fast as the global average. This accelerated warming manifests in several critical ways, each with profound implications. We are witnessing a drastic decline in multi-year sea ice, which is essential for regulating global temperatures. Simultaneously, the thawing of permafrost soils is releasing vast quantities of greenhouse gases, further intensifying warming. Additionally, the accelerated melting of continental glaciers and ice sheets contributes significantly to global sea level rise. While global warming currently hovers around 1.1 degrees Celsius, temperature anomalies in the Arctic regularly exceed the 2-degree threshold, signaling a dangerous trajectory for this vital region. One of the most concerning aspects of Arctic warming is the vicious circle created by the albedo effect. As summer temperatures rise, there is a significant decrease in sea ice cover. This reduction in ice exposes the darker ocean surface beneath. While bright ice reflects up to 90% of incoming solar radiation back into space, the dark seawater absorbs approximately 90% of that energy. This increased absorption of heat leads to further warming, which in turn accelerates more ice melt. This self-reinforcing process creates a powerful positive feedback mechanism, exponentially increasing the rate of warming and accelerating climate change throughout the region. It is a cycle that, once fully engaged, becomes incredibly difficult to reverse. The dramatic changes in the Arctic are not only environmental, but also create significant geopolitical and ecological areas of tension. As the ice recedes, new shipping routes are becoming accessible, potentially shortening global trade passages, but also introducing new risks. The region's vast, untapped natural resources, including oil, gas, and minerals, are becoming more accessible, leading to increased exploration and competition among nations. However, this pursuit of resources and new trade routes comes with substantial ecological risks. Increased human activity in this fragile environment threatens unique ecosystems, wildlife, and indigenous communities. The balance between economic opportunity and environmental preservation in the Arctic is a complex and critical challenge we must address responsibly. Beyond its surface, the Arctic plays a pivotal role in driving global ocean currents, particularly the thermohaline circulation system. This vast, interconnected network of currents, often referred to as the global conveyor belt, is driven by differences in temperature and salinity. Key components include the North Atlantic Drift, which brings warm water northward, and the Arctic Circulation System, which influences the formation of dense, cold water that sinks and drives deep ocean currents. The transpolar drift also plays a role in moving ice and water masses across the Arctic basin. These currents are fundamental to regulating Earth's climate, distributing heat, and transporting nutrients across the world's oceans, making the Arctic a critical component of this intricate global system. Recent scientific measurements reveal concerning changes in these vital ocean current patterns. The Atlantic Meridional Overturning Circulation, or AMOC, has shown a weakening of approximately 15% since the mid-20th century, with models predicting a further weakening of 25 to 45% by the end of this century. This slowdown is exacerbated by altered salinity levels. Increased melting of glaciers and sea ice introduces significant freshwater inputs, reducing the salinity of surface layers and impeding the formation of dense, deep water. Furthermore, warming Atlantic water is affecting the stability of water stratification and altering vertical mixing, which profoundly impacts nutrient distribution. These changes have severe consequences for ecosystems, influencing the distribution of nutrients, plankton, and the entire marine food chain, leading to poleward shifts in fishery resources. The potential collapse of the thermohaline circulation represents a critical tipping point for our planet's climate system. A partial or complete shutdown of the Atlantic Meridional Overturning Circulation, which includes the Gulf Stream, could trigger severe and widespread consequences. For instance, Northwest Europe could experience regional cooling of 3 to 5 degrees Celsius, despite overall global warming, leading to harsher winters and drastically altered precipitation patterns. This would also cause a significant shift in climate zones, with the intertropical convergence zone moving southward, resulting in drastic effects on monsoon regions and global precipitation distribution. Furthermore, a collapse could lead to regional sea level rise on the North American East Coast of up to 50 centimeters, in addition to the global rise threatening coastal communities and infrastructure. The changes originating in the Arctic and within our ocean systems trigger a cascade of global effects, creating systemic risks that impact societies worldwide. We are already witnessing an increase in extreme weather events, from more intense storms and heat waves to devastating floods, displacing communities and causing immense suffering. This leads to climate migration, as people are forced to leave their homes in search of safety and resources. Ecosystems are collapsing, exemplified by the widespread bleaching of coral reefs, which are vital for marine biodiversity. Furthermore, critical resources like fish stocks are threatened, impacting food security and the livelihoods of millions. These interconnected challenges underscore the urgent need for comprehensive global action to mitigate these escalating risks. The scientific evidence regarding Arctic climate change is robust and unequivocal. Observational data show a consistent 13% decline in Arctic sea ice extent per decade in September since 1979. Climate models project that we could see ice-free Arctic summers between 2040 and 2060, depending on our emission scenarios. Paleoclimatology data, derived from ice core drillings, reveal that the current rate of warming is unprecedented in the last 2,000 years, highlighting the extraordinary nature of these changes. System analyses are actively identifying critical tipping points that, once crossed, could trigger irreversible changes with profound global consequences. The Arctic's warming rate, the rapid ice retreat, and the weakening of the AMOC are stark indicators of a system under immense stress. The accelerated changes in the Arctic serve as a stark early warning system for global climate change. The interconnectedness of our climate systems means that what happens in the Arctic does not stay in the Arctic. Its impacts reverberate across the entire planet. We are facing the potential for irreversible changes that could profoundly affect ecosystems, human livelihoods, and global stability. Therefore, the imperative for drastic emission reductions, guided by robust scientific evidence, has never been more urgent. Our collective future depends on immediate and decisive action to transition to sustainable practices and mitigate the most severe consequences of climate change. This is not merely an environmental issue, It is a fundamental challenge to our civilization.